Hey, what's up guys? Today we're going to be doing inverse trig functions and the law of sines. So on yesterday's lesson, we learned how to find the sine, cosine, and tangent values of specific angles. So let's find the exact value of sine of 150, and I'm just going to show you a thorough way to do this. Right? We can draw the terminal side of our angle, right? The initial side always starts on the positive x-axis here. So that is 150 degrees, which means our reference angle, how much more do we need to get to 180? That is 30 degrees. All right, so what is the sine of 30 degrees in other words? If you forgot, you can draw a 30, 60, 90 right triangle. Right, the ratio is 1 to 2. Right, opposite over hypotenuse. So sine of 150 is going to have the same value as sine of 30. And let's think of the sines. So you can use ASTC. That means sine is positive in the second quadrant. So that is equal to positive a half. All right, tan of 330. Let me draw a 330 degree angle. It's going to end up somewhere over there. Right, that's 90, 180, 270, and I have to go 60 more. So, again, I need to make 30 degrees more to get to the x-axis. So that's my reference angle. The reference angle, again, is 30 degrees. I know tangent is sine over cosine. So this is sine of 330 over cosine of 330 degrees. Alright, so what is sine of 330? Well, the reference angle is 30 degrees, so sine of 330 is also going to equal a half. Right, but this time we're in the fourth quadrant, and in the fourth quadrant, everything's positive there, all sine, tangent, cosine. Only cosine's positive in the fourth quadrant, so sine is negative. And then what is cosine of 330 degrees? Well, again, our reference angle is 30 degrees. So if we look at this triangle, cosine of 30 is radical 3 over 2, adjacent over hypotenuse. Right, and that's going to be positive, so that's radical 3 over 2. So tangent of 330 is equal to negative a half over cosine of 330, which is radical 3 over 2. When you multiply by the denominator, we're going to get negative a half times. We're going to multiply by the reciprocal, right? That's going to equal negative 1 over rad 3. And rationalizing, we're going to get radical 3 over 3. And I forgot the negative sign. Right, so that's tan of 330 degrees. All right, so inverse trig functions. What is? Use your calculator to find the following. Round to the nearest tenth if necessary. So far we've been taking the sine of angles, like the sine of 30 degrees is a half. So this is asking the sine of what angle equals a half. In other words, what angle produces a ratio of 1 to 2, right? A ratio of opposite to hypotenuse, that makes that ratio 1 to 2 in a right triangle. So, of course we know the answer is 30 degrees because sine of 30 is a half, right? But the way to do this in your calculator is to use inverse trig functions. So if you look at your calculator, next to the button number 7, right, you'll see the trig button again. And you'll see something that looks like this, a sign with a little negative 1 above it. That is our inverse trig function. So inverse functions are just functions that undo each other, reverse each other. For example, you know if you had 3x equals a half, right? All you do is divide both sides by 3 to solve for x, because multiplication and division are inverse operations, right? Just like if you had x plus 3, let's say you're trying to solve this equation, right? You subtract 3 from both sides because addition and subtraction are inverse operations. So if you have something squared, right, you square root both sides, because squaring and square rooting are inverse operations. So inverse operations, we have addition and subtraction, multiplication and division, squaring something and square rooting something. Right? So taking the sign of something and doing this, that is the inverse of taking the sign of something, and we call this inverse sine. So the inverse of sine is inverse sine. All right? It looks a little weird, but it's just the opposite, just like addition, subtraction, multiplication, division, squaring, and square rooting. We have sine and inverse sine. So in other words, if I want to undo signing something, I'm going to inverse sine it. So I'm going to take the inverse sine of sine x. Of course, I can't just do that on one side, so I need to do that on both sides. So I'll also take the inverse sine of a half. And what happens when we do this? Well, again, sine and inverse sine are opposite operations, so they are going to cancel each other out. So we get x is equal to the inverse sine of a half. Right. So in the original, we were asking what angle, right, gives us a ratio of opposite to hypotenuse that is 1 to 2. That is a half. So when you type this into your calculator, we should be getting x equals 30 degrees. Right? And again, make sure you are in degree mode. Right? This is what you're typing into your calculator, the inverse sine of a half, and that should equal 30 degrees. But wait, if you look at the warm-up, right, we also know sine of 150 is 30 degrees. So just be aware that when you do this, your calculator only gives you an acute angle, only gives you a value between 0 and 90 degrees. All right? So just note that your calculator will always give an acute solution. Even though there might be more than one answer to this. There's actually infinitely many answers, because we could just make a full lap and then go a little more. So like, alright. But just be aware again, your calculator only gives you the first solution, the first acute solution. So x is 30 degrees. Right? But based on what we've talked about, we know sine is also positive in the second quadrant. So anytime you want a second solution, just for sine, right? For sine, you can do 180 minus this. If you do 180 minus 30 degrees, you will get another solution of 150 degrees. That's only for sine. All right? So sine of what angle is 1.4? So let's type this into the calculator. Inverse sine. Oh, sorry, let me show the work. We have sine of x equals 1.4. And again, to solve for x here, we're going to take the inverse sine of both sides. Take the inverse sine of sine x and the inverse sine of 1.4. Right, those cancel out. X is equal to the inverse sine of 1.4. Right, type that into your calculator, and you should be getting error or undefined. Right, there is no solution here, and I want you to think for a second about why. There's no solution. X is undefined. Well, remember, we're getting that result because this is asking the sine of what angle produces an opposite over hypotenuse that's equal to 1.4. Well, opposite over hypotenuse, that ratio, can never be 1.4 to 1. Right? Because that would be saying that the opposite is bigger than the hypotenuse, which doesn't make sense. So we can only be taking the inverse sine of a number that's less than 1. Right? The ratio has to be less than 1. So using this inverse sine, we can find missing angles using trig. Right? Before we were always finding the side lengths of things, but this is just using same idea, except we're going to be finding angles. So whenever you use a trig function, you need 3 things, or you need 2 out of 3 things, right? So any trig function, it's going to be the sine of an angle, right, is equal to opposite over hypotenuse if you're using sine, for example. So this consists of 3 parts, right? We have 2 sides and an angle. So if I'm looking for the value of x here, that angle, well, we have 2 sides with that angle. So if I'm trying to find the value of x here, let's think about which trig function I should use. I know the opposite side, and I have the adjacent side, so I'm going to be using tangent. So we can say tan of x is equal to opposite over adjacent. And in this case, to solve for x, I will be taking the inverse tangent of both sides. Right, so we had 2 of the 3 parts. We had the 2 side lengths, and that will let us find the angle measure. So I take the inverse tan of both sides. X is equal to the inverse tan of 8 over 10. And we're going to get, well, actually, let me just show you what it should look like in your calculator. I've copied it down here. Right, this is what you should be typing into your calculator. This is what it should look like. Bam. Right, so the inverse tangent of 8 over 10 is 38.6598. And round to the nearest tenth of a degree. Right, this number, this answer here you're going to be getting, it's an irrational answer. So just round to whatever it tells you to. So in this case, round to the nearest tenth, that's 38.7 degrees. And I shouldn't say equal, it's approximately 38.7 degrees. So if this is 38.7 degrees, I mean, we could obviously find the measure of angle y just by subtracting or adding up the angles to make it equal 180. Right, but let's do tangent of y also, right? And the reason I'm doing tangent again is if I'm looking for angle y, right, I have the opposite side to angle y and the adjacent side to angle y. So opposite over adjacent here is 10 over 8. So the tangent of this angle y gives us a ratio of opposite to adjacent of 10 to 8, or 10 over 8. So again, I'm going to take the inverse tangent of both sides, and y will equal the inverse tangent of 10 over 8. And that is approximately, again, this is what it should look like when you type it into your calculator, and you get 51.3. And as we can see, these 2 angles clearly add up to 90 degrees. And that's that. Alright, so make sure you're doing these on your calculator. When you do these on your calculator, just make sure you see that you are in degrees. Right, again, if you're not in degrees, hit the on button, go to your home screen. It only works on the home screen. And then you go to settings, document settings, and under angle, change that from radians, if you're in radians, to degrees. Right? And also, by the way, if you wanted to, you could have solved for the hypotenuse, and then you could have used a different trig ratio to get the angles, but that's just extra work. Right? Same thing here. If you want, you can use Pythagorean theorem to find that missing side length, and we can use tangent again. But with the size they've given us, if I'm looking for the measure of angle W, well, I have, in this case, this would be the adjacent side, and 7 would be the hypotenuse. So I would be using cosine. I can say the cosine of this angle W gives us a ratio of adjacent to hypotenuse of 4 to 7. And so solving for W, right, hopefully you get the idea. This is Not too bad. We're just going to take the inverse cosine of both sides. Right, inverse cosine cancels out with taking the cosine of something. So we get W is equal to the inverse cosine of 4 over 7. And I did that on the calculator too over here. So you can take a look. That's going to be 55 point, rounding, that's going to be 2. Ooh, blurry. All right, ignore the first one. The first one didn't come out correctly. But inverse cosine of 4/7, right, we get 51 point, I'm checking around to the 100th here just because it's so close. But 55.15 degrees. Right, and if we're looking for the measure of angle Z, well, we have opposite over hypotenuse. Right, so you can set that one up. Opposite over hypotenuse is sine, so I will be taking the inverse sine of 4/7 to find that one. And the measure of angle Z would be 34.85 degrees. And again, you didn't need to use trig to get the second angle value, right? Of course, we know angles add up to 180 in a triangle. Right, but just showing that it works using our trig definitions as well. All right. So let's move on, and that's inverse trig. Let's do law of sines. So draw a triangle that looks something like this. That looks too much like a right angle, I'm sorry. I want to make this an acute triangle, but not too acute looking. Maybe like... Alright, I'm happy with this one. Alright, so that's angle A, B, and C. We got triangle ABC. And what I'm going to do is I'm going to drop a altitude, this perpendicular, right, and I'm going to label that H. And let's label the sides as well. That's the length of A. Right, opposite angle B, this will be the length of B. Opposite angle C, this will be C. Alright, so let's figure out what that length of H is in terms of our other variables here. So if I'm using angle B, I can say that, well, sine of B is going to be opposite over hypotenuse, right? H over C. So I'm going to write sine of B equals H over C. And let's do that again with angle C. So sine of angle C equals opposite again, H over hypotenuse, which is B here, right? Looking at this right triangle. And I noticed the only thing these two equations wrote out have in common is H. So let's solve for H in both. So solving for H in this first one, we get the height is equal to C times sine of B. And solving for H in this one, if I cross multiply both sides by B, I get H equals B times sine of C. Right, if H is equal to this and H is equal to that, let's do a substitution. That means C sine of B equals B sine of C. And if I divide both sides by BC, just to clean it up a little, right, I'm doing it to both sides, so that's perfectly fine. What we get is the C's cancel out here and the B's cancel out here, and we get sine of B over B is equal to sine of C over C. And guess what I'm going to put here? That's going to be sine of A over A. Right, we haven't shown this yet, but we could easily do that. if I copy and paste this triangle, copy, there we go, and paste, if I draw another height and do the same exact thing, we would get that third ratio. So, for example, instead of drawing the altitude from A, if I drew the altitude from angle B, like this, right? Well, in this triangle, I would get that the sine of A equals opposite. This is our new height. Opposite over hypotenuse, which is C. And looking at the other right triangle, this guy over here, I could say that the sine of angle C equals opposite. Again, H over the hypotenuse now will be A. And we're going to see the same thing happen. We get H equals C times sine of A. And H equals A times sine of C. Dividing both sides by AC. Oh, whoops, not yet, sorry. I didn't set them equal to each other. So we get C sine of A equals A sine of C. Right, dividing both sides by AC now. I get sine of A over A equals sine of C over C. And if sine of A over A equals sine of C over C, then sine of A over A equals sine of C over C, which is also equal to sine of B over B. So all three are equal to each other. And this here is what we call the law of sines. All right, if you try to do something similar with cosine, it does not work, right? So this is saying the sine of an angle divided by the side opposite that angle is equal to the sine of another angle in the triangle divided by the side opposite of that is equal to the third one. Right? And by the way, this original triangle ABC, this was not a right triangle, right? This works in any triangle ABC. And that's the law of sines. So let's use this to solve a couple of questions. Here's our first example. Right, a surveyor needs to determine the distance between 2 points A and B that lie on opposite banks of a river. A point C is chosen 160 meters from point A on the same side of the river as A. The measures of angle BAC and ACB are 41 and 55. Approximate the distance from A to B to the nearest meter. So we're trying to look for AB. I'm going to call that X. Right? The diagram, everything's labeled already. So this is actually a really cool problem because this is something a surveyor might actually use. Like, let's say you can't cross the river and you can't figure out this distance AB. Well, you don't even need to cross the river. All you have to do is measure this angle, walk any distance you want, right? Just you can figure out how far you're walking, right? And then measure another angle to B, and then you can find the distance of AB using trig. So we do not have a right triangle in ABC, so we can't use our basic trig values, but we could use the we could use the law of sines here, right? So I'm looking for X. I have 160 meters. So let's think about which two angles we want to use. We know the sine of A over A is equal to the sine of B over B is equal to the sine of C over C. So we need like an angle and opposite side pair. So which pairs do we have? We have this side, and its opposite angle is this one. So we need to find the measure of angle B. And of course we can do that because the angles in the triangle add up to 180. So 41 plus 55 plus the measure of angle B is going to be 180. And what is that? That's 96, right? 96. 180 minus that is 84 degrees. So angle B is 84 degrees. And I don't want you to look at the letters because the letters don't mean anything, right? This could be XYZ, for example, or JKW. But just in general, right, any angle and the side opposite that angle. So I'll be using this pair, 84 and 160, and 55 with what we're trying to solve, the length of AB. So I can say the sine of 84 over 160, right? This is like our A here, if you want to call that A. This is the side opposite it. If I'm using this angle, 55 degrees, that's equal to sine of 55, divided by the side opposite 55 degrees, that's x. So to solve this, we're going to cross multiply. We get x times sine of 84 equals 160 times the sine of 55. All right, so a lot of people, either in this step or the step before, they're going to want to type in these trig values first. And they're going to be writing out a crazy long decimal. Do not do that. Just leave it in terms of sine until the very end. Because if you're evaluating sine of 84, first of all, you're going to have to keep a lot of digits if you want to be accurate. And second of all, there's just no reason to do that because there's going to be a lot of writing and it's going to be an approximation. So even at this step, I wouldn't type in either of those values yet. Let's finish solving for x. X is going to be 160 times sine of 55 divided by, I'm going to divide both sides by the sine of 84. And this is what I would type into the calculator all at once. Just one calculation, and at the very end, we can round it. So we're rounding to the nearest meter. So I'm going to type this in, give me a sec. Current. Alright, so 160. Actually, hit Control Divide first, make that fraction. 160, you hit trig, sine of 55. Again, make sure in degrees. Divided by trig, sine of 84. Hit enter. And x is approximately 131.786. Rounding to the nearest meter. The length of AB is approximately 132 meters. Alright, I'm just going to go back and do a sanity check, see if this makes any sense. That looks pretty good. I know this answer has to be less than what? Alright, if you're thinking 160, that's correct because this angle here, right, 55 degrees is less than 84 degrees, right? So if you're getting an answer like 200 meters, right, you might think that looks pretty reasonable given the diagram, but we know that's impossible because opposite a smaller angle, our side has to be smaller. So if you got something like 200, you know that can't be it, right? Anything more than 160 can't be correct. So 132 looks good, and that's using law of sines. All right, let's do one more quick example. Find the sine of angle B. So this time we're looking for angle B. We're looking for this measurement. So setting up our law of sines, we have this angle and its opposite. We're looking for this angle, and we also have its opposite. So we're just going to be doing sine of 30 over length opposite the 30 degree angle, 12, is equal to sine of B over the length opposite the side opposite angle B, which is 10. And solving for this one's actually nice because I know sine of 30 is a half. So I get 10 times sine of 30 when I cross multiply equals 12 times sine of B. Dividing both sides by 12, I get 10 times sine of 30, that's 10 times a half, that's 5/12 equals sine of B. So to find the measure of angle B now I have to use my inverse trig. If I take the inverse sine of 5/12 on both sides, I get the measure of angle B is equal to, alright, I'm sorry, I don't know why I wrote it out like that. Take the inverse sine of both sides. I get B is approximately current trig, inverse trig, control divide, 5 over 12, 24.6 degrees. Did it tell us what to round to? It did not tell us what to round to. And also, I didn't answer the question. But by the way, the measure of angle B would be about 24.6 degrees. But I'm very sorry. The question did not ask us to find the measure of angle B. It told us to find the sine of the measure of angle B. So I actually did extra work. This is if we wanted to find the angle. What is the sine of B equal to? We'll divide both sides by 12. Sine of B is equal to 5/12. Alright, that is the answer. If you did the inverse trig now to get the actual measure of angle B, B is about 24.6 degrees. Alright. Example 3. This one says find the measure of angle A if it is an obtuse angle. Alright, so again we're going to be doing inverse trig because we're looking for an angle, right? And this is not a right triangle, triangle ABC, so I'll be using law of sines again. So I see I have this angle and that opposite of it, so I can set up sine of 25 over 7. That's going to equal, well, I'm looking for the measure of angle A, but I do not know the side opposite of it, and I also cannot solve for this side, right? So if I want to use law of sines, well, I could find this angle. I could find the measure of angle B, right, because I have its opposite side. And if I know the measure of angle B, then I can find the measure of angle A because all the angles add up to 180. So I can say the sine of angle B over 11. So cross multiplying, I get 11 sine of 25 equals 7 sine of B. Dividing both sides by 7, I get the sine of angle B is equal 11 sine of 25, all divided by 7. And again, if you want, as long as you keep the values in your calculator, you're fine. But I want to solve for the measure of angle B. So before I even type this in my calculator, I'm actually going to take the inverse sine of both sides first. Right, I don't touch my calculator until I really need to. And now I can say that B equals all of this, and that is what I would type into my calculator. All right, that's equal to the inverse sine of all of that. So trig inverse sine, inside the parentheses, I'm going to have control divide, make it a fraction, sine of 25 over 7. All right, I'll just take a quick picture of what it looks like on my camera. Alright, so it should look something like this. Again, make sure you are in degree mode. Use photo. Alright, and that looks like it is about 41.6-ish degrees. 41.6144 something degrees. Alright, so find the measure of angle A. This is 41 point. Again, I didn't tell you what to round to, I'm sorry. I would definitely tell you. Let's say to the nearest tenth of a degree, so I can round this to 41.6. And then looking for the measure of angle A, that is going to be 46 plus 25, 6.6, and subtract 8. And we will get 113.4 degrees. Right, so that's definitely obtuse, more than 90 degrees. All right. And lastly, example 4. A car is moving toward a tunnel carved out of the base of a hill. As the accompanying diagram shows, the top of the hill, H, is sighted from 2 locations, A and B. The distance between A and B is 250. What is the height H of the hill to the nearest foot? So I'm looking for this height. And just looking at this right triangle here, right, there's not enough information to find the height, right? Because like we talked about with our trig, sine of an angle is opposite over hypotenuse. We need 2 out of the 3 parts, right? We only have one piece. We only have one angle. We do not know another length in this right triangle. So I can't start here, which means let's start looking at my other triangle, right? This is also a right triangle, but again, there's not enough information in this right triangle. The only thing I know about this right triangle is this one angle, 30 degrees. So that means I need to look at some other triangles, and this is the only other triangle I have in here, right? And this triangle is clearly not a right triangle, which means if I want to use this triangle, I can't just use my normal trig values for a right triangle trig. I have to use law of sines. So I can find this angle, right? Because these are supplementary. So this is 135 degrees. Those two make 165. So this angle over here is 15 degrees. And let's see if we can apply law of sines now. So I'm trying to get to this triangle, and I notice that shares this length. So I'm going to call this side x here. And setting this up, I can say sine of 15 degrees is equal to, sine of 15, opposite of that is 250. So sine of 15 over 250 equals, I have x that's across the 30 degree angle, so I can say that's equal to sine of 30 over x. This will let me solve for x. X is equal to, cross multiplying sine of 15 times x equals, again, sine of 30 is a half, so a half of 250 when I cross multiply is 125. X is 125 over sine of 15. All right. If you want, you can type that into your calculator and get an approximate answer. I'm just going to leave it as the exact answer until I really need to change it at the very end. Sine of, what was it? 125 over sine of 15. Right, and now to solve for h, there's so many ways. This is also a right triangle. So now I could use some trig ratios to solve for h. I also know this is a 45, 45, 90 degree right triangle. So I know the relationship is 1, 1, radical 2. So I can divide my hypotenuse by radical 2 to also solve for h. Right, a special right triangle. So h is equal to 125 over sine of 15 degrees. All of that divided by radical 2. Right, and let me just type that in real quick. This told us to round to the nearest foot. And so 125 divided by sine of 15 is around 482.963. Again, I'm just going to copy that answer in my calculator, divide by radical 2. Right, keep it as accurate as you can. I got 341.506 something. Right, and this is the answer I want to round. The height is approximately 342 feet. So you want to be as accurate as possible because you notice that was a 5. If you didn't keep as many digits as you were doing this problem and it ended up being like 49 or something, right, you would round down and you would get the answer incorrect. So I always try to keep my answer as precise as possible. I do not use approximate values during the intermediate steps of the calculations, right? If you did get an x value here, and you didn't want to use 125 over sine of 15, right? I would try to keep that as accurate as I could. So in the calculator, I'll probably use a value like 482 point, and I would recommend keeping, I don't know, at least 3 decimals. But if you're doing it in your calculator, you can keep all the digits. Right? So that's it for today. Right, if you have any questions on how to do any of the inverse trig stuff or on the law of sines, just leave me a comment. Right, and I'll see you guys next time.